Good night, everyone. Welcome to our crash course for IT. Can you guys see if you're seeing my screen?
Yes, sir.
All right, great. So, um, just to give you a rundown of what we're trying to accomplish for tonight, in a nutshell, basically you gotta know everything. Um, However, chapters 1, 2, 3, and 4, those are basically theory. So that's read and memorize. Chapters 5 all the way to um, 10, that's basically theory alongside practical. So memorizing the definition terms and so on, and then knowing how to carry out certain tasks using the software, like how to do mail merge, stuff like that. So we're gonna start off with programming, which is gonna be one of the most challenging topic. So we're gonna try to cover everything as it relates to programming. Then we're gonna work our way backward. Maybe touch web page. Web page. We should touch web page a bit because that is a simple chapter. And then we see how we go from database word spreadsheet and see where we go from there. So that is our goal for tonight. If anybody has any suggestions, they are free to make that known. Also, please note that I'm going to try to be going a bit fast. I know it's late in the night. Some of us sleep early, some of us don't. So, and it's a lot of contents that we need to cover. So, I'm going to be going a bit fast. So, if there is something that you don't understand, please let me know. If you have any questions, let me know. Doesn't make sense. You're here tonight and you don't learn anything because you're afraid to ask. So ask any question at any point in time for me to clarify at any point in time. All right. So any questions from anybody before we begin? All right. So to begin, we'll be starting with chapter 9.1, Introduction to Problem Solving. So basically, before you ever create a program, you need to understand the concept of problem solving. It's basically trying to break down a problem because all programs are basically trying to solve a problem. So, how do you break down a problem? Well, in programming, to break down a problem, you create what is called an algorithm. An algorithm helps you to solve a problem. Now, what is an algorithm? Your first definition for the night. An algorithm is simply a sequence of precise instructions which results in a solution. So, an algorithm is basically a series of steps, precise steps that leads to a solution. Now, an algorithm must never be vague. It must be a clear, precise steps. If in the question paper they ask you to write a algorithm, all of your steps should be very precise. It should be clear exactly what the person must do. You can't just say add two numbers. Like for instance, you cannot just say add two numbers. I mean, you can say that, add two numbers, but you need to be more specific. What are the two numbers that you're basically adding? That would be even better. So clearer is better. Now in programming, there's a phase. We basically have two phases when we are creating a program. The very first phase is called the algorithm phase. So as we just covered, solving a problem, the first thing we need to do is to create an algorithm. So in the algorithm phase, there are 5 steps. We need to define a problem. How do you basically define a problem? Break down the problem. Try to understand what is the problem. What is You basically ask questions like what is the problem, why the problem exists, what are the causes of the problem, what are the effects of the problem, how is the problem affecting you, how is the problem affecting those around you. The second step of the algorithm phase is for you to propose solutions. What are some solutions to solving this problem? Um, this is an everyday scenario kind of situation that it's not only for programming, but you think about any form of solutions and you evaluate each one of them. How do you evaluate? You basically look at the pros and cons, which is better, which is worse in various scenarios. And then step three, you select which is the most reasonable one. Now, in our case, we might select a program. So that is where we reach step number four, designing an algorithm. Now, whenever you're finished designing an algorithm, you must test your algorithm. What do we use to test our algorithm? We use a tool called a trace table. You would have covered that in your SBA. After you create an algorithm, you use a tool called a trace table to basically work through each step of that algorithm to see if it works for that program. Now, for those that just joined, remember at any point in time, if you have any questions, feel free to let me know. Now, after the algorithm phase, after you would have created your algorithm and you would have tested your algorithm with your trace table, you enter your implementation phase of programming. The three phases, the three steps of the implementation phase is one, to translate your algorithm into your desired programming language. So it's a step-by-step translation. So your algorithm is going to have step one, step two, step three, step four, how much ever steps you have, and it's simply a conversion from one step to the other step in your programming language. So you translate. The second step for your implementation phase is executing, or basically running that program, testing it to see if it is actually working. And then lastly, the maintenance phase, maintenance step, where you test your algorithm, you test your program, run updates, send out updates, make sure it is working properly as you proceed. And that's basically the algorithm and the implementation phase. Now, this is basically a summary of defining the problem. Whenever you're defining the problem, you need to specify what is the output, what are you expecting to get out of this program. Are you expecting numbers? Are you expecting something graphical? Then by knowing what you are going to expect as an output, you will know what you have to input. So for instance, if you know that you need to get as an output maybe the words excellent or maybe the word good for a particular grade, then you know your input is going to be a grade. Then your processing, specifying your process. A process is basically a calculation. So how are you going to calculate from getting a grade to the word excellent or the word good? So how are you going to do that? Maybe you might do if statement. If grade is greater than a certain number, you output excellent. Else, if it's not that, you output something else. So how are you going to calculate that? And then finally, storage. What data do you need to store from all of that? Now, before you ever create an algorithm, you need to create what is called an IPO chart. An IPO chart is simply a three-column table. This is an example of one. A three-column table documenting all the input, processing, and output of an algorithm. It basically helps you to create your algorithm. So instead of starting your algorithm right off, you can create a IPO chart. By creating the IPO chart, it will help you to document everything that you need to input, everything that you need to calculate, and everything that you need to output. And that ensures you have everything in your algorithm. So please keep that in mind if you get any algorithm questions. So we have a simple example here that we can go through. So this algorithm here, this IPO chart for an algorithm is basically to add three numbers together. So in this case here, we have three inputs. Number one, In this case, we are just putting the name of the variable. So number one, number two, number three. This indicates we have three inputs, three values. Under a process, remember process is basically what you're calculating. Add the three numbers together. Now, you could write it in that manner, basically in a descriptive manner, or you can write it in a formula manner. For example, like this here. So instead of saying add three numbers together, we could have done something like this here. Results equal number one plus number two plus number three. And that's basically the same as add three numbers together. But this is an actual formula that you might use in your program. And for the output, you list we have result of the addition. In this case, we could have simply just put the variable result because we're outputting that variable or whatever is inside of that variable. Good, that is it for our first chapter. Any questions from anybody? No? Moving on. Algorithm design. Now, when it comes to algorithm, there are two means of creating an algorithm. So we have the flowchart, which is basically using diagrams, and then we have a pseudocode, which is using English type statements. Now, pseudocode and flowchart are not like types of algorithm. They're just different ways of documenting your steps. Think of your algorithm as being a bit more descriptive. For instance, this here can be considered an algorithm that is descriptive. However, this here can be considered as pseudocode because it has a bit more of a structure. It has a bit more of a layout that you follow in terms of writing your instructions. So algorithm is a bit more descriptive. Your pseudocode has a bit more of a structure that you would follow. However, sometimes you can switch them around. It doesn't. I don't think they would penalize you for that. Now, flowchart, obviously, that is shapes, so you need to remember that. You need to remember your shapes. Now, whenever creating an algorithm or a pseudocode, you must start with a title and you must end with that keyword end. So a title is going to look something like this here, pseudocode, colon, and then title. And at the very end, you have the keyword end. Starting point and the end point for that algorithm. Now, these are just some of the characteristics an algorithm must have. It must be correct in that an algorithm must accept any and all input, even if it's a wrong input. What is meant by this here? For example, if an algorithm is specifically for a calculation, it should be able to accept letters. Why am I saying it should be able to accept letters? Because if it does accept letters, then it should have a meaningful response telling the person that, look, this is a program for calculating numbers. We would not accept letters. Please enter a number. Simple. So that's what we mean by it being correct and accepting all input. So basically indicate to the person you made a wrong input rather than the person not seeing anything and the person wondering why the program is not working. An algorithm, each step must be simple, it must be precise, it must be clear. That goes back to being clear, it must be precise, easy to implement, and must be efficient. Now, when designing an algorithm, you must use these two here, variables and constants. Now, you're creating a program. The program needs to store data. What does it use to store data? It uses variables and constants. Now, a variable or constant, another definition, variable or constant is an area or space in memory that holds data so the program might use or manipulate. Now, a constant is basically a type of variable that is going to hold a value which does not change. The term variable and constant should be a bit straightforward. Constant remains the same, variable changes. Just remember they are both used for holding, storing data. Now for examples of data that do not change, pi, VAT, discount, birth year. There are certain values, certain data that does not change. That is why we use constants. Now, when we're creating a variable or a constant, we must indicate what type of data is going to be stored in that variable or constant. So the 5 data types that you need to remember are one, so we have integer and real. These are the number data types. What are the difference? Number is for whole numbers. Real are for fractional or basically decimal base numbers. Character and string, those two are a bit related because they're both used for characters. However, a character is for a single character and string is for a collection of characters. Boolean is only used when you have two values. So for instance, if you have an answer of true or false, the answer of yes or no, only when there are two values would you use a Boolean. Now, whenever you are creating a variable, the variable must also be given a name. A variable must not start with a variable name must not start with a number. The name must be meaningful. So like for example, this here, 2 number, it should not start with a number. It can contain a number, just that it should not start with it. So number 2 instead of 2 number. Now, what is a statement? A statement is a description of the processing that can include an action. So basically, statements and keywords are like action words, like you would have learned in English. We have verbs. Think of statements and keywords as our verbs. They tell us what is going to happen. So input, read, output, display, print, write. Not seeing it there. We have if, we have for, we have while. Those are our keywords, those are our statements. They tell us what is going to happen. So input and read are our two input keywords. They basically indicate that data is going into the system. And output, display, print, and write are our 4 output keywords. They indicate that data is coming out of the program, out of the algorithm. So if you want to say a data is coming out of a variable, you can say print and then the variable results. Or you can say display result, output result, write result. If you want to input, you can say read or write, read, and then the variable num1. So that is simply why we say it's an action word. It's basically indicating that you're outputting whatever is in the variable result. You're inputting and you're storing a value into that number, into that variable called number1. Now, we have a type of statement called a conditional statement. Conditional statements are used for when you want to basically make a decision. So those are your if statements. So you have two conditional statements. You have your if then, and then you have your if then else. Now your conditional statements are also called your decision statements, as mentioned. Now, before I forget, there is a term in programming that is called constructs. Some of you may have come across this term. The constructs in programming. There are 3 constructs when it comes to programming. There is the sequential construct. There is the conditional, as you can see here, conditional or decision construct. And then there is the loop or the iteration construct. Basically, it's how you are constructing the program. What are you putting into the program? So we all know what the word sequential mean. Sequential goes one after each other. So 1, 2, 3, 4. So sequential in that the program, the algorithm is going one step after each other. That's how you're constructing the program, going one step after each other. Conditional, meaning that the algorithm, the program is going to take different paths basically based on a decision that is going to make. That is your if then and if then else statement. And your iteration construct is when you're going to be repeating certain parts of your program. Those are your loop statements, your while loop, your for loop, and your repeat loop. What is a subroutine? A subroutine is simply breaking a large program into parts. So other terms for subroutine, we have functions, we have modules, we have procedures. So say for instance, we have a large program, we divide that program up into parts, and we say somebody's going to build part A, somebody's going to build C, D, and E. So it's not just one person working on this entire program. We have 5 different people working on this program here. Now, the benefit of this here is that this person is going to be responsible for A, another person will be responsible for B. So if anything goes wrong, you basically blame that person. But having one person working on an individual part leads to a benefit because they're dedicated to that small specific task. Now, the benefit of creating a program in parts is that these parts can actually stand on their own. What do we mean by they standing on their own? Think of these like building blocks. So part A can be used first. So say for instance, we can actually use them in different order. Maybe we can start off with part A, then we can use the part C, then we can use part D, then we can jump back to A. So that is what is meant by using subroutines. You break the program into parts and now you can use those parts individually whenever you can. All right, so that brings us to the end of another chapter, chapter 9.2. Any questions from anyone? You can give me a thumbs up if you're okay so far, or some sort of emoji reaction. If you have any questions, feel free to unmute and ask at any point in time. Now, chapter 9.3, pseudocode. So we're going to focus in more on pseudocode right now, focus how to create a pseudocode. Now, please note a pseudocode is not a programming language. What is a programming language? A programming language is what you use to create a program. A pseudocode, when you create a pseudocode, you are not creating a program. As you would have learned, the implementation phase, the very first step, is you translating your pseudocode into a program. So if the pseudocode was a program, why would you have to translate it? So your pseudocode is not a program. It's not a programming code. It's basically, think of it like if you're writing a paragraph in English words. However, based on whatever language you're speaking, it can be in those words also. Now, let's look at an example of a pseudocode. So as mentioned already, when creating a pseudocode, it's better to have an IPO chart. So we are already familiar with this one here. We have 3 input, 3 variables indicating those 3 inputs. We're indicating here that we're adding those 3 variables together, and then we are going to output the addition of that variable. Now, the pseudocode for that IPO chart, 1, notice we have our title here, pseudocode, colon, and a simple yet clear title. Add 3 numbers together. You don't have to make your title too lengthy. Please remember, whatever we are naming, we do not use space. You either use no space or you use an underscore. Now, after your title, you're going to have, well, basically, it's not shown here, but after your title, you should have a declaration section. So variable declaration. And then you basically declare your variables. In this case, it would be something like num1 equal integer. And then similar going down. Now, after your declaration, you're going to have your variable initialization. And that's going to have a similar pattern. Number 1 equal whatever value. So Please remember this is the pattern for declaring. The pattern is basically the name of the variable followed by equal sign followed by the data type. When initializing, almost similar, name of the variable, instead of a data type, you put the value that it is going to start with. So right after the title, you should have a declaration section and then an initialization section. After your initialization section, then you are going to have your body. Your body is going to basically be your IPO, which is your input, output, and processing, which is basically your IPO charts. So in this case here, notice our keyword input. This keyword input is simply indicating that we are going to enter a value into the variable called number 1. Once again, we're going to input a value into the variable called number 2. We're going to input a value into the variable called number 3. So those are our input. Now here we have our output, so we can actually number it. Let me number it. So this is going to be step number 1, step number 2, 3, 4. So at step number 4, we have our process. We have our calculation. We're going to add those 3 numbers together. And then at step number 5, we output the results. And then last but not least, we have the end, the keyword end, which indicates the end of our pseudocode. So those are the 5 main parts of a pseudocode. Let me document it for you. Color that is stand out. Yeah, so 1, you should have a title. 2, a variable declaration section. 3, initialization section. 4, your body, which is IPO. And then finally, the end. Those are the 5 main parts of your pseudocode. You should have those 5 main parts whenever you're creating a pseudocode. Some parts might be missing from the question. Like for instance, in your question, they might not show you the declaration or the initialization. Don't worry with that. Just imagine it and answer the question. Now, whenever you see a symbol like this here, do you always have to get initialization? Good question. Depends on the situation. Now, let me explain to you why initialization is important. So, why initialization is important is because, 1, it gives the variable a starting value. So, like for instance, this is how basically we create a constant. So if I never enter a value into this variable called number 1, and say for instance I initialized it maybe with the value 10, and it keeps that value, and I never input a value into number 1, then it's going to keep that value of 10, thus becoming a constant. So that's 1. Now 2, why we also initialize is because of a issue by the name of garbage value. So basically the program can pick up what is called a garbage value. Now this is a bit technical. Now say for instance, this is what is called a dynamic program. Dynamic in that it accepts input. Every time you run the program, these 3 variables can change, because every time the program runs, you can enter different values. That's what's meant by dynamic. It can change. Now, say for instance, we make this program a static program. What do we mean by it being static? There is no inputs. We're not going to accept input. So a static program is when there is basically no input. However, you initialize, or basically you don't initialize the variable, or you don't give it a value. So for instance, you say add the 3 numbers together, but you don't give it a value. You don't have any initialization. So what the system is going to do, what the computer is going to do, what the program is going to do is assign random values to these here. Well, it doesn't technically assign random value. Because of how the system functions, it might just pick up a random value because of how the computer works. So if you don't initialize and you don't input a value, a variable can pick up a random value. And say for instance, now if you run this program, it could pick up maybe number 1 is now 7, 5, 3, whatever, This one is a random number. That one's a random number. Remember, this only happens if you don't input and if you don't initialize. It can pick up a random value, which is called a garbage value, and thus affect your calculations. I hope that answers your question. Any other questions from anyone? So this here is a pattern of how I want you guys to create your pseudocode. So your title is here. Pseudocode, add 3 numbers together. Let me change the color here. Now you're gonna have now if you notice all the input was summarized into one line. You can't do this here, you can't summarize. But please note you can only do this if the data type is the same. So more than likely all of these here are going to be of the data type integer. So you can only do this once it's the same. Otherwise, it would need to be read number 1, read number 2, read number 3. Now, whenever you're doing a process, it should look like a formula. However, our formula is a bit different. Our total is on the left-hand side rather than the right-hand side. So how our formula is structured is that our calculation is on the right-hand side. And then whatever we get from that calculation, we store into a variable on the left-hand side. So notice we have an equal sign. This is basically saying carry out the calculation on the right-hand side, store it on the left-hand side. Now, what I missed was this line here, this arrow. Now, if you notice this arrow here, this arrow is basically also an equal sign. So it's basically saying the same thing, but it's a bit more straightforward. It's basically telling you add whatever's on the right hand, store it on the left hand. So you might see an equal sign or you might see an arrow. Now, as I told you guys already, we have 3 constructs. So notice your sequential statement. Please remember this is one of your construct. And as mentioned already, your sequential construct is basically the algorithm, the pseudocode, the flowchart going one step after each other. Sequential statements are executed one after the other from the start statement to the last. Straightforward. Now your second construct, called your conditional branching, conditional statement, decision statement. You might see those different terms. Please remember we have 2 types of conditional statements, conditional branching. We have the if then and we have the if then else. Now, whenever you see if, you're basically, think of it like you're basically asking a question. Think of it that way. If something is greater than, if something is less than, if something is equal to, if something is not equal to, whatever the case may be. Now, whenever you see the keyword then, think of true. And whenever you see the keyword false, think of, whenever you see the keyword else, think of false. So basically, it's like a true or false question. Whenever you ask the question, it's either the answer is true or the answer is false. There's no middle ground. So that's why we have the then and we have the else. Now, the if-then statement only considers true statement. Please remember that. If-then only considers true because literally there's no else here. So it only considers true. The if-then else statement considers both true and false. So what to do if it is true, what to do if it is false. So an example of the if-then statement, we have a title here, pseudocode, add 3 numbers together. We have step number 1. We are inputting a value into number 1, number 2, number 3, number 2. Step number 2, we are adding those 3 numbers together, storing it into total. Now, if that total is greater than 50, step number 3, now say for instance, total is 60. If 60 is greater than 50, now what you should do here at this point in time, question yourself, ask it in a question format. Is 60 greater than 50? Yes, that means the answer is true. That means you have to look at if the next step has a true, if it has a then, or if it has an else. So we know that then represents true. That means we have to carry out this then statement here. So we print what is in total. Print means to output. So we output what is in total. What is in total? We display the value 60. And if is to indicate the end of an if statement, and then we end our overall pseudocode. Now, if you're noticing, I am literally writing on the screen, um, literally writing next to the variable. You should practice this while you are reading your pseudocode. Write the actual values next to your variable so that you know what value they contain. Because, say for instance, you're entering a loop, you will have to remember what value it contains from the previous loop. This is where writing that value will help you. Now, let's just go it over. If it was false, what would happen? So say for instance, total is 40. Now if 40 is greater than 50, so remember ask it in a question format. Is 40 greater than 50? No. That means the question is false. The answer to the question is false. Now what do we do with step number 4? We ignore it. Why are we ignoring it? Because then is only carried out if the question is true. So we literally ignore it, move on to the next step, the next logical step, which is the end of the if statement and the end of the overall program. Well, those aren't step numbers, so let me erase that. But that's the end of that there. Remember, once again, if you have any questions, let me know. Where's the if then else? All right, let's look at one final example of the if then and then move on to if then else. So here we have a title. We have step number 1. We're going to input a value into mark. Now say we input a value and that value is going to be 90. Now we're going to ask our question, is 90 greater than equal to 80? Yes, that means that is true. Step number 3. Now the first thing we need to do is to output excellent results. Step number 4, output please see your teacher. Now an important point here to note is indentation. If you notice, these two lines here were indented. Why were they indented? They were indented to indicate that they fall under this then statement here. That's the purpose of indentation. Indentation, once you see something indented, it means it's under a particular statement or a particular keyword. So in this case, these two statements belong to this then keyword. So that means if this was true, or if we look at it from the other perspective, which would make it clear that if this was, say for instance, 40, then that would be no, which is false. Then that means we have to ignore everything here. We have to ignore both step 4 and step 3 because of indentation indicating they are both under this then statement. So you have to be mindful of indentation. Yes.
Sir, so for the steps, wouldn't you say that step three governs both outputs? So wouldn't you just put step three for the whole thing?
No. Because as we would have covered just now in algorithm, each step must be logical, each step must be simple. So you're not supposed to complicate a step by having multiple actions inside of them. So a step should be one simple logical action.
Okay, thank you.
Now, our next conditional statement, the if then else statement. So remember, else considers false. So let's look at an example. Yes. So here we have our title, pseudocode, add 3 numbers together. Step number 1, we're going to input a value into number 1, input a value into number 2, number 3. Step number 2, we're going to add 3 numbers together, store that into total. Now say for instance our value is 60. Step number 3. Now is 60 greater than 50? Yes, that means that is true. Now step number 4, that's our then keyword. So that means we have to carry out this step. We're printing total. What is in total? We're printing 60. Step number 5. Step number 5 is our false action. That means we have to ignore it. And the opposite of that, just for clarification's sake, Basically, if this here was 40, is 40 greater than 50? No, that means it's false. Step number 4 has the then keyword. That is only carried out if it is true. We ignore that. Step number 5 is carried out. We print the sum is less than 50. All right, so this is the last example of the if then else statement. So we have a title here. Millie is a teen. We are going to input this year. So step number 1, we input this year. This year is 2024. We input the birth year. For simplicity, we're going to just type 2000. Now, step number 3, we're going to do a calculation. 2024 minus birth year, that's going to give us an age of 24. Step number 4, is 24 less than 13? No, that means our answer is false. Step number 5, that is only carried out if it is true. Step number 6, our answer is false. It is else. We carry this out. We output Millie is not a teenager. Then we end. So remember, end if is to indicate the end of that if statement. You can draw a bracket like this here so that you can know clearly where the if statement is starting and where the if statement is ending. And then we have our end keyword to indicate the overall end of our pseudocode. So that's basically our 2 conditional statements. Any questions from anybody? Now, a nested condition is basically putting one if statement inside another. Nested basically meaning putting something inside another. So in this case, we're putting one if statement inside another. So this is where bracketing can help you if you can't visually tell them apart. So title here, pseudocode, exam results. Step number 1, we're going to input a mark. I'm going to input 60. Now, if mark, so this is step number 2. But what I'm going to do, I am going to block off from here to here. So that way, I know that this is the start of the if statement. This is the end. How do I know that? Remember our keywords, if, then, else. So that's the start, that's the end there. Now, step number 2, is mark greater than equal to 80? So is 60 greater than equal to 80? No. So that is false. So step number 3, do we carry that out? No, because that's the then keyword. We also ignore step number 4 because indentation, that is a part of the then keyword. Step number 5, our answer was false. So that means we have to carry out the else. What to do under the else? We run another if statement. Now, if you notice, this if statement is an if then statement. So we have a combination of if then else with a if then. Now, at this step here, we're checking to see if mark is greater than equal to 70. In this case, it is 60. Is 60 greater than equal to 70? No, that there is false. So, step number 6. Step number 6 is only considered if it is true because it has a then keyword. So, we ignore that also. Now, because of sequential statement, remember we're going one step after each other. So we're going to go to step number 7. We output, please await the end of term report. Then we have the end of the if here. Why the end if there? All right, let's not think too much about that. All right, moving on to loops now. Now, a loop has 4 main parts. First, a loop would have input a starting value. So a loop would have a starting value. Starting value is a specific variable determined. All right, not a starting value. A loop would have a specific variable. All loops would have a variable to basically indicate whether you should enter a loop or not. That's the first part of any loop. Number 2, that variable is going to have a test to see whether, once again, you will enter the loop or not. Number 3, the loop is going to have a body. So if you enter the loop, you execute the body. And number four, that variable is going to have an update. That update is basically to increment the variable so that you can cycle through the loop, and basically to also indicate that you're actually going through that loop. So all loops have these four main parts: a variable, testing the variable, the body, and an update to that variable. Now there are two main types of loops. We have the indefinite loop and we have the definite loop. The indefinite loop is used when we do not know how many times the loop should run for. So say for instance, we just don't know. Now those loops are the while and the repeat loop. Now when we do know how long a loop should run for, say we want to run the part of the program for 10 times, 20 times, we use what is called the definite loop. And an example of that is the for loop. So please remember the two types there. Now, what is very important to remember is the difference between the while and the repeat loop. They usually test you on this here. Now, the while and the repeat loop. So, the first difference that you should take note of is where is the condition. Now, the condition is this test here, basically testing it against the conditions, part number 2. So, where is it? Now, in the while loop, the condition is before the body. And in the repeat loop, the condition is after the body. So that's the first difference. And then vice versa, where's the body? The body is after the condition in the while loop. In the repeat loop, the body is before the condition. So that's your first difference there that you need to remember. Now the next difference that you need to remember is when do you enter the while loop, when do you exit the while loop. Same for the repeat loop. Now for the while loop, you enter the while loop when the condition is true. So that means you exit when it is false. And it is basically the opposite for the repeats. Whatever is one way for the while is the opposite for the repeats. So if the while loop is true to enter, that means the repeat loop is going to be false to enter and true to exit. So you need to remember those four differences. Where's the body? Where's the condition? How do you enter? How do you exit? Now, the other difference, let's see, let me find a blank space. Let me find a blank space. All right, doesn't work here. All right, so how we usually teach this part is think of the while and repeats loop like it's maybe like a garden, like you enter in a area. Now the while loop is going to be imagine the while loop having a gate at the beginning here. So this condition has to be true. This is while. This condition has to be true in order for you to enter this body here and execute this loop. It have to be false in order to enter. Now, for the repeat loop, there's literally no gates. Let me draw it properly. There's literally no gates. So you simply enter and you run the loop. And it has to be true in order for you to exit. So if it is false, you basically stay in the loop. Now, why am I drawing this here? Because the other difference you need to remember is how often will the loop run for? The other difference is basically how often will the loop run for. So the while loop has the probability. No, the question, what you need to remember is basically what is the probability of entering the loop or having it run? So the probability of the while loop is that it will never run. The probability is that it will um, never enter. So if you keep getting the answer false, basically, you will never enter the while loop. Now, the probability of the repeat loop is that it will run at least once because there's nothing stopping you from entering the repeat loop. This goes back to where is the condition. This goes back to where is the condition. So the condition for the repeat loop is at the end. So that's why for this image here, I'm drawing it this way here. You're entering and the condition is at the end here. So you enter the body for the repeat loop, you run it once, but then you have the possibility of exiting. So there's the probability that the repeat loop will only run once. Now for the while loop, because the condition is at the beginning, there's a probability that you will never enter. You will never run this loop. So that's another difference there that you need to remember. I'm looking for, all right, let's look at an example. Yes. Um, are you guys still seeing my screen? Are you guys still seeing?
Yeah.
All right, great. So an example here of the while loop. So we have a title here at the beginning, pseudocode numbers in a loop. Then we have step number one. We have an initialization here. We are initializing number with the value 1. Step number 2, we have our while statement. So where does it end? We look for the end while. Now, while number is less than 3, so we also ask this in the question format. Is 1 less than equal to 3? So yes. Now, if we go back to our um, here, so what to do when the while loop is true, we're supposed to enter that loop. We exit if it is false. So if we go back to the example, is this true? Yes. So that means we enter into the loop. So as we enter now, step number 3, we add 1 to a number. Now this here is our update. This is an example of an update. An update is basically adding 1 to a variable and then storing that value with the very same variable. So it's basically like adding 1 because we initialized here with 1. So it's 1 plus 1, which is 2, and 2 gets stored inside of that variable. Now, as mentioned before, this is where writing the answers next to the variable is going to be beneficial. So step number 4, we output the number is, and then the number that is inside of the variable, which is going to be 2. Now remember, this is a loop, so you have to go back to the top. So when we go back to the top, this here is now going to be 2 because it was changed throughout this body here. So, and this is where denoting where is the start and where is the end is going to be helpful. So we ask back the question again, is 2 less than equal to 3? Yes. So we go through the same process. We go to number 3. 2 plus 1, that's going to be 3. Then we output the number is 3. Then we go back to the top again. Is 3 less than equal to 3? Yes, so that is true. And we go back to number 3, step number 3. That's going to be 3 plus 1. That is going to give us 4. We output, the number is 4. Then we go back to the top. We have 4 here. And then we ask the question, is 4 less than or equal to 3? Our answer is now going to be no, which is false. And what do we do when the while loop is false? We exit. We ignore everything here and we go to the complete end, which is at step number 5, output end. Sorry. Yeah, output out of loop. And those are the steps there. Any questions on it? So remember, true to enter, false to exit for the while loop. All right, one final example of the while loop, and then we're going to move on to the repeat. So we have a title here. Then we have tree initialization. So we initialize that with 0, 0, 0. So we enter a mark. So we're going to enter 60. Step number 4. Sorry, I mixed it up. Now, note this is called a prompt. A prompt is basically giving an instruction to a person. So you don't always do the declaration. That's what I was explaining earlier. Now that you don't always need to declare, in the textbook, it doesn't often indicate declaration, and in some test questions, they don't indicate it. But just imagine it is there and answer the questions accordingly. But if you are to write one, ensure you do indicate the declaration and initialization. So your output, yeah, so this here is a prompt, basically giving a person an instruction. You input a value into mark, so we're going to say we're going to input 60. Now, while mark is not equal to -1, so this might be a bit tricky. So while 60 is not equal to -1, is 60 not equal to -1? That is true. Now, for a while loop, what do we do when it's true? We enter that loop. So total is 0 plus mark, so that's going to be 60. We add that into total, that's going to be 60. Count is 0, 0 plus 1, 1. Output, enter mark. So this is 7, 8, 9, 10. Output, we have another prompt here. Input a mark, so we're going to input 60 again. So we go back to the top. So while mark is not equal to 60, I enter 60 again. So that means it is true. So now it's going to be 60 plus 60. It is going to give us 120. Count is now going to be 1 plus 1. It's going to give us 2. And then we're going to have enter mark. So I'm going to end it here. I'm just going to put 0. Sorry, I'm going to enter -1. This is basically a mechanism to end the program. So by entering -1, -1 is not equal to -1. So that means it's going to be false. And then we ignore everything here, end the program. Now total is going to be, so that's step number 11. Total is going to be 120 divided by what is in count. So that's going to be 2. Step number 12, so that's going to be 60 stored inside of average. And we output the value that is inside of average. And then we come to the end of our while statement, while loop there. Any questions on this here? Now, just for clarification's sake, remember we looked at the program must have, the loop has 4 parts. It has a variable, testing the variable, a body, and an update. So if we look at the examples that we looked at so far, it has a variable. In this case, the variable is mark. That's 1. It has a update. That's count. That is that's basically enter the mark. Yeah, enter the mark is our update here. we have a condition, checking to see if it's not equal, so that's number 3. And we have the body. Everything here is the body. So notice our 4 parts there. Now the repeat loop, remember the repeat loop is basically the opposite. When it's true, you exit. When it is false, you enter. So if you remember one, just remember the opposite for the other. So an example of the repeat loop, we have our title at the top here, numbers in the loop. First step, we initialize with number 1. Second step, we have our update here. So notice our variable, our update. So that's going to be 1 plus 1. And if you notice, there's nothing stopping us from entering the loop. So this is what I was saying earlier. It has the possibility of running only once because you're entering the loop right away. Nothing stopping you from entering the loop. Now we have our update 1 plus 1. So that's going to be 2. The output, the number is, what is the number? 2. Now we are to do this until number equal 3. Now, is 2 equal to 3? No, that means it is false. So remember, the repeat loop, false means you have to repeat. You have to stay inside of the loop. You only exit once it is true. So this here is false. We go back to the top. So repeat until. So this is going to be 2 plus 1. So 2 plus 1 is going to give us 3. We output, the number is 3. And we reach step number 3 until 3 number equal 3. So is 3 equal to 3? Yes, that's true. So we exit this repeat loop here. And then we output out of loop. Any questions?
Sorry, could do the over?
All right. Do the one over or go to another example?
Another example.
All right. Let me look for the last one. I think this one has a combination of repeats and something else. All right, so let me look at this one here. All right, so here we have a title. Here we have initialization. We're initializing age with the value of 18. We have a repeat until. Now repeat, we're going to output you are under 20 years old. So that's step number is 1, 2, 3. So age 18 plus 1, that's going to be 19. Now until age equal 19. So we're going to ask the question, is 19 equal to 20? That's false. What do we do when the repeat loop is false? We repeat. We go back to the top. We remember this is the start here. So the next step is step number 2. Output, you're under 20 years old. So now it's going to be 19 plus 1, which is going to be 20 here. So now it's going to ask us, is 20 equal to 20? True. 20 is equal to 20, and we exit. One more example. So you have a title here, attend classes, input the day. All right, let's not look at that because that one usually confuses us. All right, this one here. This is a good one. Now, title, average of exam marks. I'm going to take my time with this one here. So we have initialization here, total equal 0, count equals 0, average equals 0. Then we have step number 4, display enter mark. So this is our prompt. Step number 5, we input a mark. So I'm going to input 60. Step number 6. So this is a combination of loop, if statement. Yeah, loop and if statement. So where are we? Step number 5, input a mark. I input 60. Step number 6. Now, if mark is equal to -1. So is 60 equal to -1? No, so that means that is false. What do we do when that is false? So this is an if statement. So if, then else. Then display. So that means we have to ignore this here because then is the true statement. So we carry out the else. So total plus mark, so that's going to be 0 plus 60, which is going to be 60 here. Count is 0, 0 plus 1 is going to be 1. Now, we're still in the body of the repeats, so we have to go to, that's 7, that's 8, that's 9, this is 10. So at 10 here, we're going to check is mark, is 60 equal to negative 1? The answer is no, 6 is not equal to negative 1. So that means false. What do we do when repeat is false? We repeat it. We go back to the top. So we go back to the top here. We display step number 4, enter mark. We input another value. I'm going to input 60 again. Step number 6, is 60 equal to negative 1? No. So that's going to be, I didn't need to erase that. So that's going to be 60 plus 60. That's going to give us 120. Now this is going to be 1 plus 1. That's going to be 2 over there. Now 60 is going to come back at the bottom here. Same result. 60 is not equal to negative 1. And we go back to the top. Now at the top here, we're now going to enter negative 1, the mechanism to end the program. Now if mark is equal to negative 1, now because it is, so now it is true, now we carry out step number 7. We display end of marks. So that's a statement. We ignore the else, and we go all the way to step number 10 until mark. So we're seeing whether we have to stay in the loop or not. So this is negative 1. Is negative 1 equal to negative 1? That is true. What do we do when a repeat loop is true? We exit. So when we exit now, we have another if then else statement. If count is equal to 0, is count equal to 0? No. It has a 2. So is count equal to 0? False. What do we do here with it then? So this is 11, 12. We ignore here. Then we carry out 13. That's here. Now we take the average total. What is total? Total is 120 divided by 2, which is the count. We get our average of 60. We output step 14, 60. So that's it for that example there. Any questions from anybody? So remember, for the while and the repeat, when you exit, when you enter. For the repeat, you exit when it is true, you enter when it is false. For the while, it's opposite. You enter when it is true, and you exit when it is false. Now the for loop. The for loop, this is our definite loop. This is what we use when we know exactly how much time to run the program. Now, this is the structure of the for loop. So you have the for keyword, our variable is going to go here. Now, this equal sign is basically our updates. You're going to notice as we go through the example, there is no update. This equal sign here is basically our update here. It's going to update with a start value. Now, if you're counting up, you have to use the word to. So if, say, for instance, you're going 1 to 10, you can use that keyword there. Now, if you're counting downwards, you're going to say 10 down to 1. And then, so that's your start value, that's your final value, and then the keyword do. Then you have your statements, and then the keyword N4. So let's look at our example. Not that one. Yeah, so let's look at this one here. So title, step 1, for countdown. So notice we have our variable. This is our update here. If you notice, there is no, as I told you guys, update is usually a pattern of this here. A variable equal that same variable plus 1 is going to have a pattern of this here. This here is basically going to be the same variable name. Now, if you notice, you don't have that here because in a for loop, it already knows that it needs to go from 10 to whatever, or 1 to whatever. So it self updates by this equal sign here. So countdown gets initialized with this 10 here. So 10 gets stored in here and it's counting down to 1. So step 1, it gets initialized with 10. It outputs what is inside of countdown. So as you can see, it outputs 10. And then it goes back up again, initializes with 9, outputs 9, initializes with 8, output 8, and it keeps going like that until it reaches 1. So the for loop is a bit more simpler loop because you know exactly how many times you're running it for. So the condition is basically here also. It has to be within 10 to 1, and then you have your body here. So the 4 parts are still here: variable, update, the condition, and the body. Let's look at another example. So you have a title here. Step number 1, for number. So remember, this is going to be initialized with 1, 2, 2. Step number 2, output, the number is. What is inside the variable number? 1. Now, take note of this here. Whenever you're outputting a phrase, it's going to be in double quotation marks. If you're outputting a phrase and a variable, separate it by a comma. Variables do not go into quotation marks because whatever is in a quotation mark means output exactly what is in a quotation mark. So if you ever put a variable in a quotation mark, like for example, num in quotation mark, exactly the word num will be displayed. So this case, output the number is 1, and it goes back to the top. Output the number is 2, and then you exit because it only goes 1 to 2. Step 3, output out of loop, and then you end for an end. That's basically the for loop. All right, let's go to this final example for loops. Title, sum of even numbers. You have initialization with 0, initializing with count with 1. Step number 3. Now, if count is even, so is 1 even? No. Then we ignore this here because that's only considered if it is true. However, it is false. That is 4. Number 5. Now, notice this should have been, well, this here is indented to show this is a part of here. And this here is coming under here. So for this case, you would have to look at the where is the repeat, where is the until. So we have our update here. 1 plus 1 equals 2. Repeat until count equal is greater than 20. So is 2 greater than 20? True. What do we do when the repeat loop condition is true? We repeat. We go back to the top. And we go through that cycle. If count is even, yes, now it is. So that means we carry out step number 4. We add the sum. 0 plus count is going to be 2. And that 2 gets stored inside of sum. And we go back and forth until it reaches greater than 20. Any questions, comments? All right, so that brings us to the end of pseudocode. Moving on to flowcharts now. Now, everything that you would have covered in pseudocode is basically the same that rolls over to your flowchart. The same rules, the same principles apply. Now, the only difference is that you got to remember the symbols because you got to write your instructions inside of symbols. So we have the oval shape that is called your terminator shape. This is where we're going to have the start and end the keywords inside of. So, for example, notice we have start and stop inside of our oval shapes. if you're asked to draw a flowchart. So just like how your pseudocode must have a title, start with a title, and must have that end keyword, similarly your flowchart must have a start and must have a stop to indicate that. So that's one. Two, your parallelogram. Your parallelogram is basically used for your input and output instructions. So whenever you want to input something, whenever you want to output something, so input, output. Three, your rectangle is for your process, which is basically your calculations. So all calculations go into a rectangle. Number four, your diamond is used for your decision. Decision is your if statement. Now the diamond, let's look for an example. Good. The diamond is usually going to have one input and one or two output, depending on the if statement that is used. So you would know what, as you remember, the two if statements that we covered, we have if then and then we have if then else. So depending on the lines that are coming out, that would indicate whether it's if then or if then else. So if you have two lines, that would indicate it's a if then else. If you have one line, that would indicate you're using a if then. A circle is used as a connector symbol. What is a connector symbol? Now, if you notice a flowchart, um, if you are drawing a flowchart, it can take up a lot of space on a single page because you're going downwards all the time. So one way to indicate that you did not end on one page, but rather you're continuing from that page to another, is use a connector. So maybe at the very end of the page, you're going to have this here to indicate that that's not the end of the flowchart, but rather you are continuing it somewhere else. And then on the other page, you start off with this here. So this is the end of the page. This is the beginning of the page to indicate that this is part of the previous connector. This is going to go to the next connector. That's one way it can be used. The other way it can be used is going back to the concept of subroutines. So a flowchart can basically be segmented, a different part of the algorithm, the flowchart. So just imagine if this here had a connector like this here. So ignore that start. Let's imagine there was a connector here, and there is also a connector here. So basically what this means is that this flowchart here can be plugged into any other flowchart because this can be the starting point, this is the ending point. So from one flowchart is going to flow into here, and then as it goes through this flowchart, it flows out to another one. So that's the other purpose of the connector, to basically plug in a piece of a flowchart. Now lastly, your last symbol for flowchart is your flow lines. Your flow line basically indicates the flow of data. It's very simple. You just watch how the lines are going and you follow that direction. Now it's for sequential flowcharts, it won't be that necessary, but especially when you're going to come across a flowchart that has a decision symbol, that's when it's going to be important for you to know what direction you need to go in, especially if the like in this case here, the data flow actually goes back upward. Now, when it does this here, that would be an indication of a loop. So if you notice, a certain part is being repeated. So flowcharts are actually much simpler than pseudocode because you're just following symbols, you're just following lines. Now, so those are your symbols that you need to remember. Let's see. So as mentioned, every flowchart must have a start symbol, a stop symbol. Now this here is a summarization, just in case you missed it. The repeat loop has a process before the decision. So that's one difference there. That is, a repeat loop will always execute the process at least once. So that's what I explained in the program has the probability of running at least once. The while loop is generally the reverse. The decision comes first after the process. So that means the while loop is usually drawn. So it loops while the condition is true, and the repeat loop repeats while it is true also, until it is true, basically. Now, just like how we learned about sequential statements, flowcharts also have sequential statements in that it goes from one chart to the other, one symbol to the other. Sequential meaning one after each other. Now, your conditional statements, same to your pseudocoding algorithm. As I was saying, if your, where is it? Oh, it still has two lines, but it basically is not doing anything. So let's look at this example here. Now, so we have a start, then we have an input. So remember, a rectangle is used for input and output. So we input this. Sorry, this is a process. What am I saying? That's a rectangle. So we have initialization here. This year equals 2019. Now we're going to input a birth year. So input that's 2000. Now we're going to do a calculation here. So that's this year, 2019, minus 2000. That's going to give us an age of 19. Now we're going to ask the question, is 19 less than 13? No, 19 is not less than 13. So we output I think something's wrong with this one. Student is a teenager. 19 is not less than 13, right? Yeah. Yeah, something's wrong with this one here. And then there. So, all right, let's move on to the next one. All right, so we start here. We input the mark, 60. Now, is mark greater than or equal to 60? Is 60 greater than or equal to that? No. So we go straight to the bottom here. So basically, this is not doing anything if it is false. So if you notice, it goes straight to the end here. So not doing anything if it's false is basically just a if-then structure. However, if it was 80, and the question is 80 greater than or equal to 80, yes. So we output excellent results, then we output see your teacher, and then we end the flowchart. So this is an example of an if-then flowchart. It's doing nothing if it is false, just going straight to the end. The if-then else. So this is going to do something if it is both true and false. So here we have start, input 3 numbers. We're going to add those 3 numbers together. Just say for sake, that's 60. Now, if 60 is greater than 50, yes. We go down this path here, follow the line, print total, which is 60, and then we stop. So flowcharts are much simpler to follow. You just follow the line, follow the instruction. If it was false, you come back this way, print the sum is less than 50, and then you stop there. Now nested, similar to your pseudocode, nested meaning one inside of each other. So let's go through this example here. So notice we have 2 decision symbols. So we input a mark, 60. Now, is mark greater than equal to 80? Is 60 greater than equal to 80? No, 60 is not greater than 80, so we go this direction. Now, is 60 greater than equal to 70? No, we follow the line again. So we output, please await end of term reports, and we come downward. Remember to follow the arrows. So this is where following the arrows are going to be important. Now, say for instance, it was 90. Is 90 greater than 80? Yes. So we output excellent results. That we output, please see your teacher. Output, please await the end of term reports. Very simple. Just follow the lines. Now, as mentioned, a loop in a flowchart is basically going to be looking like a line going back up. So you won't see um, repeat or while. You might not. You may not. But once you see the line going back to the decision or going back somewhere up to a previous step, you could tell that is basically a loop. So here we have initialization. Remember, that's a process symbol. Number is being initialized with 1. So we ask a question, is 1 less than equal to 3? Yes, 1 is less, so we go down. We have an update here. And you should remember from the loop, update is usually part of a loop. So that can even tell you that you are running a loop here. So that's going to be 1 plus 1, that is going to be 2. So we output, the number is 2. We go back to the top here. 2 is 2 less than equal to 3. Yes, come back down. We do another update. 2 plus 1, 3. We output 3. We go back up. Is 3 less than equal to 3? Yes, come back down. 3 plus 1 is going to give us 4. We output 4. Go back up again. Ask the question, is 4 less than equal to 3? No, we come out and we end there. So notice a loop there. But then, remembering the differences between the while and the repeat loop can help you to determine whether this is a while or repeat loop. So if you remember that the condition is before the body, that will help you to remember that this is a while loop. For instance, now, look at this one here. The body is before the condition. So this is a repeat loop. Remember the repeat loop, you have the guarantee of it running at least once because you're going through that body before anything stops you. So in this case here, numbers being initialized, numbers being updated here, 1 plus 1, that's going to give us 2, output 2, and now we're meeting, sorry, that's 2. Now we're meeting our condition. So for the repeat loop, condition is at the bottom, the while loop, the condition is at the top. So 2 here, is 2 equal to 3? No, we go back up, and we do the same process until we get it true. So once again, remember the repeat loop, the condition has to be true in order to exit, false to enter. So that is even showing right here. All right, let's go through this one here. All right, so you have a start, sum equals 0, you have initialization here, count equal 1, another initialization. Now, is count an even number? So is 1 an even number? False. So we follow the line, we go down. Count plus 1, what is count? Count is 1. 1 plus 1, 2. Follow the line. Is count greater than 6? Is 2 greater than 6? No. Follow the line, go back up, and then we are back here. Now count now has a value of 2. So is count an even number? Yes. So we follow through. Sum equal sum plus count. What is sum? Sum is 0. 0 plus 2. 2 gets stored inside of sum. We follow the line again. Update count. 2 plus 1 is going to give us 3. Here is going to be 3. Is 3 greater than 6? So we go back up, we go that process over and over. Eventually, this is going to be 7. And then is 7 greater than 6? True, display whatever is inside of sum. And then we end that flowchart. Great, so that brings us to the end of flowchart. Any questions? All right, moving on to 9.5. Now, you should remember this from maths. Basically, we have different types of operators that we're going to be using for our various calculations. We have the arithmetic operators, which are your addition, subtraction. Asterisk is used for multiplication. Forward slash is used for division. We have mod for modulus. Now, what is the difference between mod and division? Mod or modulus is basically division, but it gives you how much values are remaining, not the division factor. So what I mean is that if we divide 3 by 2, that is going to give us, what is that basically? 3 divided by 2, where's my division thing? 2. Yeah, that's going to give us the answer of 1.5. So that's division. Now, if we did modulus, modulus is basically going to do the division, and then how much is the actual whole number remaining. So the whole number remaining is going to be 1. So basically, you just do a subtraction of how much this time can go into that, remain a whole number, and you do the subtraction. So that's 2 can go in here one time, and the whole number remaining is going to be 1 there. That is modulus, how much whole numbers are remaining. Now, your relational operators are basically your comparison operators. Those are your equal, greater than, equal, um, more than, equal to, and so on. Now, for the science students, this might be familiar to you. You have your logical operators. Your logical operators are going to be your and, not, and or. So to just give a summarization of this here, now, your not is basically an inverse. So say for instance, something is one way. If you use the not operator, it's going to be the opposite. So if something is true and you use the not operator, it's going to be false. It just inverses it. That's just a summary of that. Now, like for instance here, true gives us false, false gives us true, 1 gives you 0, 0 gives you 1, the inverse of it. Now, you might see something like this here in your exam. This is called a AND operator. Now the AND operator, think of like literally the word AND is like this has to be true and this has to be true at the same time. That's as simple as I can explain it. So mark has to be greater than or equal to 70 and term has to be equal to 3 at the very same time in order for you to get a total overall true. So whenever you see the AND operator, everything has to be true to get an overall true. So that can be represented, is there an actual, no, but that can be represented here. So, oh sorry, not that part here, up to here. So if you notice, that can be represented here. True and true gives you an overall true. Any other combination for the AND operator gives you a false. So why is this important? If you have an if-then statement, remember then is only carried out if it is true. But if you have an AND operator, you have to take into consideration both questions. And you're only going to get an overall true if both questions are basically true. So that's it for the AND operator. Now the OR operator is basically either or. This can be true or this can be true, as the name literally implies or. So either one can be true and you're going to get a true. Whether one is false, the other is true. Whether the first one is false, this one is true. Or even if this one is true and the other one is false, doesn't matter. Once at least one of them is true. So as we can see in this table here, true and true gives you a true. True and false, at least one true gives you a true. Even if it's false and true, gives you a true. And overall false gives you a false. So whenever you come across the OR operator, either one can be true and you get an overall true. And then you carry out that then statement because you have a condition of true. Any questions in the logical operators? All right, let's just run through this part here. Now, the term desk check-in is the process of reviewing an algorithm for the correct processing and outputs. So that term there, you might come across it, desk check-in, reviewing an algorithm. Now, what you use to review that algorithm, you use what is called a trace table. So desk check-in is the process, but the tool that you actually use is called a trace table that helps you to test and verify your algorithm. Now, how do you create an algorithm? Sorry, how do you create a trace table? So we're going to use this pseudocode here to create this trace table at the bottom here. Now, a trace table is basically a documentation of your algorithm, step by step, to indicate what value it has at a certain point in time. So, for instance, this very first step here is to read quantity. Now, this is a one-time read. So if you notice, 4 was entered here. So in the heading, you would usually enter your variables. So if we go, let's number algorithm first. Step 1, 2, 3, 4. That's basically it. And this here is 5. So we need to pinpoint our algorithm, our variable for each step. So in step number 1, we have quantity here. Step number 2, we have sold here. Step number 3, we have multiple variables, but there's a main variable that is invoice. I think that's invoice. That's here. And step number 4, val here. So we have our variables that is making up the heading for our trace table. Now, we need to basically go through the algorithm and document our answers um, across the board, basically. So we read quantity, 4 was entered, 4 here. Now, 4 sold, so we have a loop here. That's going to be going 1 to 4, which is in quantity here. Two variables matching up here. So at this step here, at step number 1, so this should be 1 there. Now, sold is going to be initialized with 1. Now, what is the, hold on, let me, I don't think this is 1. For sold, that's going to be, I think staying up is having a tool on me. For sold, is this going to be across the board? All right, so let's just try to work it out. For sold 1, I and V is going to be, let's just use 0. I and V is going to be 4 minus 1, so that's going to be 3. Val is going to be 3 minus 1 times, so that's 2 times 5 is 10, and then we end there. We go back to the top. Quantity is still 4, so sold is going to now be 2, because remember it's a for loop, so it's going to be incrementing. So it's going to increment from 1 to 2. Now this is going to be 2. Quantity is still 4, so that's 4 minus 2, which is going to give us 2 here. Yeah, I think I'm heading in the right direction. So that's 2 minus 2 inside of sold. That's going to be 0. So 5 times 0 is going to be 0. Am I correct? 5 times 0 is 0, right? Yeah. Sold, go back to the top. That's going to be 3. So this is going to be 1, 2, 3. That's going to keep incrementing. At this line here, I and V, let me erase it. So no, I can't erase it because I gotta Remember what is our value? Start for the last one, isn't 14. Which last one? Which line are you talking about? Let me number it, see, for val. Last one as in line number 4 here? Or here? First line. Maybe I did the calculation wrong. Let me check it back. Um, let's see. So this is 1 to quantity 4. So 1, good. So 4 minus 1. So that's 3. And that's going to be 3 minus 1. So that's 3 minus 1 is 2. 2 times 5 is 10. Am I correct? Still getting 14? Multiply. Oh, and well, multiply and subtract. Okay, well, all right, we're gonna work with that. Multiply and subtract, all right. So 3 times 5 is 15 minus 1, 14. All right, good. All right, good. So sold is gonna be updated to 2. So quantity is still 4. 2 minus 4, that's going to give us 2 over here. 2 minus 2. So in that case, so 2 times 5 is 10, and 2 minus that is 8. What values? 2 here. So then this is going to be 8 instead of 0. Let me know if I'm going good so far. So that's going to remain 3. 3 to that. So 3, 4 minus 3, that's going to be 1. 1 times 5 is 5 minus, let's solve 3. 5, 2. And v is 1. So that should be 3 minus 2. The numbers are mixing me up now. 4, let's see, sold is 4. That's going to be 0. Okay, so this is counting downwards. That's 0. 5 times 0 is going to be 0. Sold is now 4 minus 4. So it's going to be 0 minus 4. It's going to be negative 4. Yeah, so, well, that's the basic idea. I think I'm getting too tired. Oh, it's actually here. So, well, we got the right work in there. Any questions from anybody? All right. All right, so we still have a bit more for programming. Just some additional information. So the term source code, if you come across that term, source code basically refers to what a person is writing in a particular programming language. So for example, for those of you who worked on your SVA, when you are typing your code in Pascal, we we call that your source code. So that's basically what you convert your algorithm into. Now we already covered that. So for syntax errors and logic errors. So a syntax is basically a structure of something, how you're supposed to structure something. Now, like for example, in English, you would have learned about subject-verb agreements, how the verb must be in a particular location, along with the subject and so on to have a well-structured sentence. Now, similarly, in programming, a, there's a certain syntax, there's a certain rule that you must follow when you are writing a certain statement. Like for instance, let me go to an example. Like for example, um, like for example, this here, this line here, the syntax or the structure is that you must put the keyword, right? You must open a bracket. You must open a single quotation mark, and then you can enter your phrase. Then you must close that quotation mark, close the bracket, have a semicolon. That's what's meant by syntax. So if you don't follow that, or you miss out any one of that bracket, or you don't follow that pattern, that's what is called a syntax error. Now, a logic error is basically one that it does a wrong calculation, basically. So you might have basically typed in the wrong sign, the wrong operator, basically. So, like for instance, if you're doing num1 plus num2, but instead of putting a plus, maybe you put an asterisk. So it gives you a wrong calculation. Nothing is wrong with it. Nothing is wrong with typing num1 asterisk num2, but it's giving you the wrong output. So that's called a logic error. Now, when it comes to programming languages, there are three types that you need to remember. We have low level. Now, between that, we have what is called the assembly language, and then we have the high level. So 1, 2, 3. So the low level language is basically what is also called machine language. It's basically binary. Now, before assembly language, before high level language that we're using today, all programs were written in binary. So imagine a person was actually writing a program using 0 and 1. Now, because that was a bit difficult, we moved on to the assembly language. Now, the assembly language is basically, think of it like abbreviation. So it abbreviated the binary code with certain keywords. Like for instance, add might have been this binary code here. Not saying it is, just saying this is an example. So you might have use the keyword add and then indicate your values instead of typing the binary code. Now that was still a bit difficult. So we moved on to now what we're using today that is called high level languages. Now a high level language is basically in English words. So it's basically like if you're writing a sentence, you're writing a paragraph, you're writing a story. So the advantage of that is that basically anybody could write a program today because they're using high level language. So high level languages are programming languages like Python, Pascal that you would have used for SB, C, C++, C Sharp, and all of those stuff. Now, we already covered what is syntax. Syntax is basically the structure as to how something must be written. So if you ignore that structure, you commit what is called a syntax error. Now, in addition to syntax, what is the semantics? Semantics is basically the meaning associated with a certain word. Like for instance, in Pascal, the semicolon means the end of a statement. Similarly, the keyword input, the semantics of that, the meaning of that is that you're entering a value into the program. So semantics just refers to the meaning of certain words, symbols, punctuations, and so on. Now you don't need to memorize the Pascal programming. They don't. They're not technically supposed to bring Pascal questions. Um, so we're not going to spend too much time on that. Now, what is all right, let's go back here. So we have the three levels of programming language. You have your low level, you have your, let me write it in the opposite order. You have your high level, you have your assembly, let me not keep that there, and then you have your low. Now, as mentioned already, low is the machine language, that is your binary. Now, a high level language must be converted into low level language in order for it to be run as a program. Now, you need some converters. These converters are called translators. So these translators have to translate from high level to low level, assembly to low level. So our translators are, we have the interpreter and we have the compiler. Now, for those who would have worked on the program, you would have noticed every time you're running your program, you'd have to hit a command called compile. So that is your compiler. Your compiler basically translates your high level language into your low level language for you. Now, your interpreter also converts your high level into low level, but there's a difference between your compiler and your interpreter. Your interpreter um, translates one line by line. It translates line by line. So just remember that for interpreter. They're both used, interpreter and compiler, they're both used for translating high level to low level. However, your interpreter translates line by line, whereas your compiler it will translate everything at once, basically. Then you have, is it the assembler? Yeah, your assembler translates your assembly language into your low level language. So these are your three translators: interpreters, compilers, assemblers. Interpreter and compiler is for high level to low level. Assembler is for assembly language to low level language. All right, so we're not gonna cover all of that. There's a lot of just reading. All right, so that brings us to the end of programming. Majority of our programming content. So if anybody has any question, you can let me know. Otherwise, we're gonna take a 5 minute break. I need a 5 minute break, and then we're gonna continue with some of the other software, either web page. In the meantime, y'all could maybe message, put it in the chat whether what software you prefer, whether spreadsheet, database, Word, or web page. One of those four that we should continue with. So we can resume in 4 minutes, 55, or somewhere around that, along that time. If you have any questions, post it. Post whatever software you want us to continue with. what the question is in. Yeah, we can start back at 10. Let me relax a bit. We are going to continue. Um, well, basically, what we're going to look at is the software, and so that can help cover some practical parts along with some theory in one. So we're going to start off with spreadsheets. Um, so remember tomorrow the paper two exam, they're going to basically asking you some questions along the line of how to do certain things. So, for instance, so we're going to go through some of the major options on these ribbons. Remember, you have to memorize where these options are so that you can basically document step by step how to make use of them or what they are, how to use them, and so on. So the very first one in the Home tab, we have the Format Painter. So for those who might not be familiar with the Format Painter, the term format basically refers to changing the appearance of something. Formatting includes all of these options that we have here, such as bold, italic, underline, changing the background color, the font color, size, and so on. Those are your formatting options, changing the appearance. So the purpose of the format painter is basically to apply a format from one location to another. So say for instance, we have a word here and we apply some formatting to it. Just going to run through this quickly. So, and you want that format to be applied somewhere else. It's simply clicking on that format, selecting the format painter, and then selecting your designated cell that needs to be applied to. So that's the purpose of the format painter, to apply format to another location. Now you should already be familiar of the various fonts, font styles, all these options here. Um, Wrap text. What is the purpose of the wrap text? The purpose of the wrap text is basically to wrap information inside of a cell. So if information is too long, it's basically going to um, wrap it around in that cell so that it fits and shows it like this here. Instead of extending outside of the cell, like for instance, let's see, like that there. Instead of extending outside of the cell, wrap text wraps the information around the inside of a cell. Doesn't appear to be extending or resting basically across other cells. For merge and center, we have we have three options actually. So they're pretty straightforward. Um, Now we have merge and center. Obviously, that groups cells together and it enforces the center alignment. Now you have merge across. What is merge across? Merge across basically merges the rows together. So if you notice, I highlighted a few um, columns and rows here. So if I select the merge across option and we look at these here, notice only the rows were merged. So that is the merge across option. It only merges the rows together. And then we have the merge cell, which is basically going to merge everything together, except it's going to keep the alignment. So notice the word is at the left there instead of over here, which is the center. So this one here is the merge and center, whereas merge keeps the merge cell keeps the alignment. What else do we have? All right, so under the insert, so we have a pivot table. What is the purpose of a pivot table? A pivot table is basically used for summarizing your data. So remember that's under your insert tab. How do we create a pivot table? you basically highlight your data, or you click on the table. Um, you click on the table, go to the Insert tab, select your pivot table, and the box will appear. You highlight your range and you select where you want your table to appear. So just two options to create in your pivot table: selecting location and the data range. Once you select OK, pivot table name is invalid. To create a pivot table, it didn't select the range correctly. Yeah. And then you simply, they might ask you the steps to creating a pivot table. You simply drag the necessary fields into the necessary rows and columns. So pretty straightforward. Whatever is in the column box will appear in the column. Whatever is in the row box will appear in the row. So notice the girl numbers are in the row. The boy numbers are inside of the column. Now the value is to basically have values appearing inside of the table. Now, there are two types of pivot table. There is the one-dimensional pivot table, and then there is the two-dimensional pivot table. The dimensions refer to whether it has columns and rows. So if it has only column or only a row, like for instance, if a field is only in the column, there's nothing in the row, that's called a one-dimensional pivot table. Vice versa, if there's something in the row, nothing inside of the column, that's also a one-dimension pivot table. If you have something in both the column and the row, that's called a two-dimension pivot table. Now, I remember there was a question a while back about this sum option, like for instance, how to change it. So you basically select the summary option and you go to select value field settings. And here you can change your summary option, whether it's sum, count, average, max, min, whichever is needed for your pivot table. So that is your pivot table there. So you have pivot charts. Remember, the pivot chart is created from your pivot table. You have your variety of charts. You guys might be familiar with these here. But with regards to the chart, you have to remember what each chart is basically used for. So let me see if I can pull that up. Um, There is charts. Charts. Yeah. So a pie chart basically used for showing a relationship between two values, not two values, between the values of a whole. A bar chart and column charts, basically for comparing similar values. The line and scatter is used for showing trends. So they might ask you questions along that line. What is the purpose of a certain chart? Um, Remember when creating a chart or asking for directly instructions as to how to create a chart, you have to highlight your data with heading in order to create a chart. So for instance, you must highlight your heading along with the data, because if you only highlight the data, you will not get a proper chart. Highlight the data to get a proper chart. Let's see. Remember, a pivot chart is created from a pivot table. Um, Charts automatically update. That's another key point to remember. So say for instance, we have a chart here and we change the value, charts automatically update. However, a pivot table does not automatically update. So if you notice, I changed this boy value from 8 to 9. However, this pivot table here did not change. I still have a value of 49 here. So how do we update a pivot table? So to update a pivot table, you have to right click on it and select the refresh option. That's going to update the value in the pivot table. Page layout. What other options? So if they ask you a question about the name ranges, that is under the formula tab. You have the name manager. That is where you would edit your name ranges, delete your name ranges, or even if you want to create new name ranges. That's the name manager under the formulas tab. Data tab is where you import, and that's that for there. Now, some functions that you need to remember. So we won't go through the simple ones. Those should be straightforward. But the first question we should ask ourselves is, what is the difference basically between a function and a formula? So a formula is basically just a equation. It's going to have a value, it's going to have a cell address, or you're going to have a range basically, but it's going to have an operator inside of it, either an addition, subtraction, multiplication operator, any operator. However, a function, the difference between a formula and a function is that a function does not contain, you do not need to type in, more specifically, you do not need to type in an operator. The function has the operator built into it. So all you need to do is type in what is called arguments. Now, the average function is used to calculate an average. The count A and count functions, these are used for counting a group of cells to see what if they contain any data inside of it. So this counts a range to see if it has numbers inside of it, how much contain numbers. Count A counts to see basically if it has any form of data inside of it. Remember, it's not counting up the data, it's basically just counting the cells to see if it has data inside of it. So for instance, count A, if it were to count this range here, it's going to get 4 because it's counting it to see how much cells would have data inside of it. However, if you use the count on this range here, you're going to get 0 because count only counts numbers, and none of these have numbers inside of it. Now you have the count if, which will count based on a certain criteria. Remember, whenever you come across the word criteria, think of question. So you're basically asking a question. For instance, if something is less than, if something is more than, if something is equal to, based on that range. So you might look at the range and ask if something is less than 10, how many values are basically less than 10? You have the date function. The date function is basically used to indicate the date. You just simply specify the cell that has the year, month, and day. You have the today function, which is used for giving you the current date. You have the if function to give you an example of that. Some of you might not be too clear on that. So equal if, equal if a value, say for instance this value here is greater than maybe 100, then the if function has 3 arguments. You have a test first there. Now the second argument is what to do if it is true. So whatever you want to occur, if that value is actually greater than 100, if you want a phrase to appear, you would put it in quotation mark, like for instance, yes, and comma to go to the false part, and then we enter a no. So, well, what cell did I use? F5. So 30, we're still going to get no. If we enter 120, we're going to get an actual value. Now, a nested if function, similar to programming, is that wherever we have true or false, we can actually enter another if function. So we can, once we understand the same structure, we continue with if, open bracket. Now, if that value is greater than 200, then what to do if it's true? Output greater than 200. Then what to do if it's false, we output false. And just like you would have learned in maths, whenever we open a bracket, we close it. So if we enter 201, all right, so this here needs to be 300. Yes, so we have 201 there, greater than 200. So you have your main function, which gives you your minimum value, max, which gives you your maximum value, PMT. PMT is used to calculating your loan. So the structure of that. So say for instance you have an interest rate of 10%. So that's your interest. You have 4 years to repay. You have a 2 million loan. So this is the payment. So equal PMT. The rate comes first, followed by the number of payment, which is going to be the years, followed by the actual loan. So it's just entering the values into that function and you get your payment. Now, if your value is in years, if you were actually giving your values into years, then you're going to get a yearly repayment as an output. So if the question asks you to get a monthly output and your input is years, then you need to do some conversion. So for instance, the 10%, which is going to be yearly, you need to divide that by 12 to give you that yearly, monthly interest, along with your year, multiplying that by 12 to give you your monthly amount. So this now is your monthly payments. So remember that conversion there. Your other function, your rank. Well, rank is basically for ranking a particular group of data in a particular order. So say for instance, we have a group of grades. We can do rank equal rank dot eq. It has 3 arguments. You have to select the cell that has the argument inside of it. Select the cell that has the value inside of it that you want to rank. Then you have your range. That's going to have the data inside of it that you're comparing it to. And then finally, the order that you want to rank it in. So whether ascending or descending. Now, let's see. Now this here, just for, yeah, that's it basically for the rank function. Sum is straightforward. Now last but not least, the one that might give you the hard time, VLOOKUP. So VLOOKUP, in summary, looks at a table, finds a value, and basically does something with that value. So in our case, let's see, we can type back boy, 89, so equal VLOOKUP. So remember your first argument for your VLOOKUP is going to be a lookup value. You can actually type in a value or it can actually be a cell. It's basically what are you looking for. So in this case, we're looking for the value 89. Now, where are you looking for it? In this case, we're looking for it in this range here, H1, H2 to L4. So the first one, what are you looking for? Where are you looking for it? Next, when you would have found that value, now what's important to note for VLOOKUP is that it only looks at the first column. When it is looking first for this value, it only looks at the first column. So that's why I typed 89. I can't use any other value from the second column. It only looks at the first. So when it has found the value in the first column, then it looks vertically. V in VLOOKUP stands for vertical lookup. So when it has found that value, it looks vertically, and then you have to indicate which column you basically want to select you want to connect with basically. So you count the columns in the range. This is 1, this is 2. And in this case, we're going to basically connect with 2. And you have to indicate whether the table was sorted or not. True is to indicate the table was sorted. False is to indicate it was not. So in most cases, we can put false because we don't know whether it's sorted or not. And false will always give us a correct answer. So those are the functions that you need to remember. Now the concept of relative and absolute addressing. What is relative and absolute addressing? So if you notice, whenever we have a formula, let me create one quickly. So say for instance, we have 1 and 1, 2 and 2, 3 and 3. So if we did equal dot plus dot, and we copy it, and we look at the cells, the calculation, the formula, sorry, you will notice that the cells actually change. So as it was copied downward, so let me delete what's at the bottom here. As it was copied downward using autofill, the cell names change. Now that is called relative addressing. When the cells change based on the location that is being copied to, that is called relative addressing. Now there are certain cases where you may not want the cell to change. That is what we call absolute addressing. So for instance, one method of absolute addressing is using the dollar sign. So we put a dollar sign before the letter, a dollar sign before the number, and when we autofill, that M7 will remain. So that's one method of absolute addressing. The other method of absolute addressing is basically to name that cell. So we name the cell, and we autofill, and it remains as that cell. So that's your two method of absolute addressing. Now another thing to take note of, this at the when you click on a cell, you notice a little square at the end here. Yes, this is what we use for autofill, but this little square has a name. It is called a fill handle. So please remember that, the fill handle. Right, let me scroll up a bit and see if I missed anything. Please remember all formulas follow BODMAS. We have title locking. Title locking, also called freeze pane. So remember that is used for freezing a column, freezing a row. That is under the View tab. So under the View tab, you have the freeze pane. You have the freeze top row, which is going to freeze the top row. So as you scroll down, the first row is in view at all point in time. Then you have the freeze first column. So if you scroll to the right, that first column is going to be in view all the time. Why is it column K? Yes. So that's title locking. To fill formulas and functions, values. Remember in Excel, we have two types of data. There are labels and values. Labels are basically all letters, names, symbols, and so on. Values are basically a number. What is an active cell? An active cell is basically a cell that is highlighted. So, where is it? Like how this cell here is highlighted, that's what we call an active cell. Seeing that we're on this screen here, if you ever come across this error message here, or anything looking like this here, this is an indication that the data is basically too large to fit inside the cell. So the means of fixing this here is basically to extend the column. If you come across the term cell reference is basically the name of the cell, reference in the cell using the name of the cell basically. Um, the advanced filter, let's look at that one there. So how to use the advanced filter. So say for instance you have a table, boy, girls, there's some random data inside of it. Good. So whenever you, if you have to give the instructions to create the advanced filter or something along the line, remember you have to create first what is called the criteria. So you highlight your headings, you place your headings below, and underneath that now is where you're going to type your criteria. So here you can type maybe on the girls greater than maybe 50. You're looking to see which girl got greater than 50. Then you go to the data tab, select your advanced option, and in this box here you can either filter in place or copy to another location. You highlight the range that has the data. So that's your second option there. You highlight your criteria range. That's your third option. And then lastly, you select where the data is going to go. So you have your output there. Now, just like how we covered in programming with your logic operators, you have your criteria, you have your and your or criteria. So say for instance, let me delete this here. Say for instance, it has to be greater than, both of them has to be greater than 50. So this is your and in the same row, and then this here is going to be your or in different rows. So we're going to see the results of the two of them. Extract. So this is your and. So notice we don't get the results because there's no boy that's greater than 50 and a girl greater than 50 at the same time. None of them. However, for the or, which is in different rows, just like we covered before, it's going to be either or. Once one is true, you are going to get a output. So notice because this one here is true, we got this output here. And because this here is true, we got this output here. So same as your logic operators. All right, we already looked at pivot table. We already talked about 1 dimension, 2-dimensional pivot table. And we talked about how they're updated. We talked about the types of charts. All right, let's move on to database now. Now, let me open a database. All right, so if you notice, when the database is open, a table is automatically created. So the first point to take note of is that in a database, data is stored in tables. So we first need to remember this structure here, that in a database is made up of tables, and in those tables, a row is called a record. Now, a small piece of data, think of it like if it's a cell, that is called a field. And the headings of a table is called the field name. So you need to remember this general structure. So generally we can say a row of fields is called a record. A group of records, make up a table, and a group of table make up a database. Excuse me. Um, so going back to the database, if you notice we have our table here. Now, all tables must be designed first in order for you to enter data into your table. So as you can see here, we have the field name. The field name are basically your headings. So I'm just going to enter one quick field name there. So that's going to give us our headings. If we switch over to datasheet view, we can notice that heading appearing there. Now, your table has two views. It has the design view and the datasheet view. What's the difference between the two? Design view, as the name implies, is for designing the table. Datasheet view is for viewing and entering your data. So here we can enter our data in the datasheet view. Now going back to design view, you name the field here, and we have our data types. So the data types are straightforward. Short text, remember short text has a limit of 255 characters. Long text is for longer text, and the rest are straightforward. Now, each table must have a primary key. You basically enable a field as a primary key by highlighting it and then selecting that primary key option. Now remember, a primary key must be unique, so that's why by default, an ID field with the data type of auto number is automatically created whenever you open a database table, because auto number automatically increments a number 1, 2, 3. There will never be a number that is repeating itself. Now let me just type in student ID. Let me just rename this here as student. Let me create another table. Subject ID, subject. So we have another table here, and a third table to basically link those tables together. So in a database, a third table will usually be used for linking two tables together. So you need a common field between both tables in order for them to be connected. That's how relationships, so the next thing we're looking at is relationships. So let me change this over to short text so that we can get it working. Short text. So remember, creating your relationship is under the database tool tab. You go to relationships, you add your tables that you want to have in your relationship. How do you create a relationship? Remember, why I'm showing you all of this is because you have to, some questions will literally ask you to document the steps. So you click on the field from one table to the next, drag it upon the corresponding field. So that is student ID to student ID, and then you enforce referential integrity. Remember, if you do not enforce referential integrity, you will not get the correct relationship. So let me go it over again. So say, for instance, you do not enforce referential integrity, it's going to look like this here. This is basically an open relationship. We don't want an open relationship. We want either a one-to-many relationship or a one-to-one relationship. And the only way to get that is to enforce referential integrity. So we enforce. Now, we have a one-to-many relationship. We have one, many. It can either be an infinity sign or it can be a M symbol indicating many. Now, what does the one indicate? The one indicates that this side here is unique. There is no student ID that is going to be repeating itself. The many side indicates that this student ID is going to be repeating many times. So if you think about it logically, in the student table, it's only going to be documenting one student, information for one particular student. So that there's no need for the ID to repeat. However, in the link table, that one student is going to be doing many subjects, is going to be studying many subjects. So that ID would need to repeat to match up with the many subjects. Remember, you don't type information multiple times into a field. So you got to type it into multiple records. So that's why it has to repeat multiple times. The subject ID, we drop that on the subject ID and force, and we also have a one-to-many relationship on this side. One subject ID to one subject. However, that subject will appear multiple times in this same table here to indicate that multiple students studying multiple subjects. Now, if it was a one-to-one relationship, a one-to-one relationship is usually between two primary keys. So let me see if it is going to. No, I don't think it's going to allow me because that is yeah, that's a. But let me just show you how what it's going to look like. Link with this as a short text. So if I drag that and that, so a so notice a one-to-one. So that's a one-to-one relationship. Now, if you notice, a relationship can be created with different fields. However, it's not recommended. It must be similar fields, similar data. If you notice, I had to change the data type in order to get this to actually work. So relationships must be created among similar fields, similar data type, so on. So you get a one-to-one only between two primary keys. You get a one-to-many basically between a primary key and a non-primary key field. All right, so that's it for your tables. Remember each table in the design view has a field property section. The field property section is basically for formatting each field. So for instance, if we look at the field size option, that is basically for limiting how much characters can go into the field. So for instance, the default for short text is 255 characters. However, we can reduce that so that persons don't enter more than a particular number. Maybe we don't want the person to enter more than 10 characters. That's the purpose of field size. Then we have input mask. Input mask is usually like if you want to give a certain pattern. Maybe the person is entering a phone number. So we show them a pattern of how to enter the phone number. Maybe it's a country code, then whatever number comes after, where the hyphen has to go, and so on. We have these two options here, validation rule and validation text. Now, you might enter a certain validation rule. So, so this might be to limit what the person can enter. So it might be that the person cannot enter a value less than something or greater than something. So if you want the person to basically type maybe over 1000, you enter a validation rule that it must be greater than 1000. Now, what is the relationship between that and the validation text? If the person violates this validation rule, the validation text will appear. So you can basically write an instruction in the validation text telling the person what to do, basically why they encounter the error and what to do to basically fix it. So those are some of the common ones you might come across. Now the create tab is where you're going to find a majority of your necessary objects, your table to create, your query to create, your form, and your reports. Now let's go through the query. Yes. So your query wizard, all of them are going to look basically the same. It's basically you're selecting the table that you want the data from, you add the field, and you basically confirm everything else. Now, especially for the query, you must go into the design view to add your criteria. So just like how we covered for the advanced filter, There's also the and criteria and the or criteria. The same principle. If you type both your criteria, if you have two criteria, say for instance, if you have greater than 10 here, and you also have greater than 30 here, just saying for example, this is the and criteria. And the same principle applies. Both question has to be true in order for you to get an output, in order for you to get a result. Now this one is a bit easier because it literally has an or row. So once something is down there, doesn't matter which order, then that is a or criteria. Now we have a show box here. So if something is not checked, it basically will not be displayed in the outputs. The 2024 paper had a similar question. How much fields will basically be displayed based on the query? And all the boxes were checked. So if all the boxes are checked, that's basically 2 fields are going to be displayed. Just above that, you have your sorts, straightforward. That is to indicate or to set whether the data is sorted or not, whether you want it sorted. The table row is to indicate what table the field is from, and the field row is to indicate the name of that field. So that's a breakdown of this area here. Now for the form, what is the purpose of a form? The purpose of a form is to link to a table. All forms, they are basically, the definition of a form is that it's a graphical representation of a table. So a form is basically linked to a table. So as you can see here, this form, the information is from that table. So if you notice at the very bottom, it's saying 1 of 1, because if we open the student table, there is only one record. So if we go back to the form and we click on the arrow, we can actually go to a new record and type in data inside of it. So we added information via the form, but we go back to the table. Now this just needs to be updated. I notice, oh, I didn't save the form. Save. Let me close the door, open the student table. I notice the information is inside of the table. So the form and the table are linked together. Whatever you add to a form updates in the table. Whatever you add to a table is also updated in a form. And then lastly, a report. What is the purpose of a report? The purpose of a report is basically to summarize your database, to give you a presentation means of your data. So a presentation of your data so that you can have a final output of your data. The benefit of the report, though, is that unlike the table, which you have to separate your data. So if you notice, the student data is here, the subject data is in another table. The benefit of a report is that it can group all that information into one location. That's the benefit of a report. You can have all the information in one location. And that is the, let's see, anything else from the top here? No, so you just need to remember your tables, queries, forms, and reports. External data tab is basically used for importing and exporting your data. And the only main option we use under the data tool tab is basically your relationship option. Help is only if you need help, which we might need. So remember your table, query, form, and reports. They're called objects. Objects in your database. Well, we already covered the database types. Remember for your field names, whenever a field name is being created, just like in programming and anything else, there's certain rules you must follow. It must be meaningful. It should not contain any space. Should not start with a number. Generally, the same rules apply whenever you're naming something. Field length is basically the same as field size, setting the limits to a particular how much data can basically be entered. Primary key. What is the purpose of a primary key? It is used for identifying a record. So that's like how you have an ID number that identifies you. A primary key is used to identifying a record. I'm trying to look for the table with an option with that. Anyway, now the other keys that you need to remember are the candidate key, composite key, and the foreign key. So what are the difference between them? So the two actual keys are the primary key and the composite key. So those are two keys that you can create. The primary key and the composite key, those are keys that you can create. The primary key is a single field. Composite, meaning something is made up of two or more of something. So a composite key is basically a primary key that is made up of two or more fields. Now a candidate key, you don't set that, you don't create that. That's just a concept. So it's basically a field that can become a primary key. Just for reference, this is what a composite key looks like. Notice the two key symbol next to two fields. This is what a composite key looks like. Now going back to candidate key, a candidate key is basically a field that can become a primary key. So um, just imagine if this here did not have a key. So this would be a field that is not a primary key. So this would be a candidate key. It's not a primary key, but it's unique enough to become a primary key. So it's kind of like how we have our ID number. Oh, it's still light. Kind of like how we have our ID number, and we also have our passport number. So if we have a table with both ID and passport, and maybe we made this our primary key, this is not. This is now considered our candidate key because it has the potential of becoming a primary key. Just that we did not set it. Now, what is a foreign key? A foreign key is simply a a field that is a primary key in one table, and it is not. Well, it could be a primary key, but it's basically used in another table. So let me see. There is a like this here. So in this table here, this would be the primary key. In the product table, the product ID would be the primary key. Now, this field here is being used in over here, so this would be the foreign key because that field is being used over there. Same with here. This is the primary key, but because that same primary key field is being used over here, it's also called a foreign key. So once a primary key field is being used in another table. All right, we already talked about relationships, one to one, one to many, and what's the difference? Remember, I also said it could be a M, and it must be a common field. We already talked about forms. Forms are basically linked to a table to enter data. And we talked about the query. Now, let's see. Are there? Yeah, we already talked about the query. Now, there's one thing we did not. Oh, this here. So please remember this here, the asterisk. whenever you're running a query, you can make use of the asterisk. The asterisk is called a wildcard. So if like if you're running a query like this here, it's basically the wildcard is used to represent unknown data. So this is basically like saying, um, give me all of the products, the description of the product that starts with the letter R. That's what this is basically saying. Or if you do asterisk R, that's basically saying, give me everything that ends with the letter R. Or if you do asterisk R asterisk, that's basically saying, give me everything that has a R inside of it. It could start with a R, end with a R, or even have a R inside of it. That's what it's basically saying. So that's the wildcard operator. Now, you have what is called a reverse query. A reverse query is when you don't want to see something. So, like for instance, if you say not Lou, at most criteria you're going to say if something is greater than 10, if something is less than 10. Well, what if you don't want to see something? That's where you can use the not operator. So, not Lou will basically exclude that person from the list. Oh, this is one to take note of. How to create a calculated field. So a calculated field is obviously used in database. It's used in the query. So a simple formula you need to remember. You first create a new field name. Now this new field name can have space. So maybe just in case they do give you a trick question along this line, showing the field name and it has space, and you should know that a field name must not have space. This is called a virtual field, so that's why it's allowed to have space. It's not an actual field. So you put the name of the field followed by a colon, and then the expression or basically the formula that you want to do your calculation. So the fields go in squared brackets, and then you have your operator. So this is basically the quantity field multiplied by the cost field, and then that value gets stored into the, or basically placed in this field called the total cost. So that's um, the syntax, and this is an example here. So remember the fields has to go in square brackets, but like say for instance you want quantity plus 5,000. The 5,000 would not go in square brackets. The 5,000 would stand on its own. Now, the calculated field can actually be used with words, but it's in terms of the words being grouped together. So like if you use the and operator, it's just gonna group the two words together. The same process, the same syntax, the new field name, colon, the field, but if you use the and operator, it's gonna group the fields together. So if you need space between it, you literally need to put two and operators with double quotation marks, and then you put that single space in between them. Oh, if you ever come across this here, this occurs when um, it's not recognizing the field. Maybe the field name changed or the field name was typed incorrectly. It doesn't exist anymore. So basically, it's not finding a particular field. So like for instance, it's not finding this field called quantity, QNTY anymore. So you get enter parameter value. So let's remember why you get that particular error. All right, so we're finished with programming spreadsheet database. We can jump to web page. quickly run through that. All right, so a web page is a document that you view using a browser. So you use the language called HTML. Now, just like pseudocode, how we said a pseudocode is not a programming language, HTML is also not a programming language. You're not creating a program, you're creating a website. HTML is called a markup language. So HTML stands for Hypertext Markup Language. It's called a markup language because you're basically marking a document. Because you basically, whenever you create an HTML document, you actually have to type the information, type in everything, and then mark in that document how it is basically going to be formatted. So that's why it's called a markup document. Now, HTML contains codes called tags. So just to memorize you, HTML common tags, just to memorize you with some common tags. You don't need to necessarily memorize them, but just in case you do come across them, I'm just going to share some of the common ones. Um, yes. So some of them are pretty straightforward. Like for instance, but this is the pattern as to how a tag would look like. You have what is called an opening tag and a closed tag. It's kind of like an open bracket and a closed bracket. And in between is where you would type your data. So that's why it's called a markup language, because you're literally using these tags to mark the document, to mark the web page document. So this is called the bold tag. So literally in whatever you put in between here, like directly where I'm putting the cursor, it would get bold. So notice the tags would usually be between these double arrows. The opening tag would just be the double arrow and a particular letter or word. The closing tag would be that similar letter or word followed by, well, before it would have a forward slash. So the one on the left is called an open tag. The one on the right is called a closing tag. So this is the bold tag. Href, ahref is for creating hyperlinks. So if you want to make a link clickable, you would use that link, that tag. Body is for the body of a HTML. What else? H1, H2, H3, those are for headings, for heading tags. I'm just showing you the simpler ones. So some of them literally are a bit straightforward. I would be for italics and so on. Now, what's important to remember, parts of a URL. Yes. So parts of a URL. Let's see which one to use. Yes, we're gonna use this one. So the very first part of a URL is the protocol. Now this protocol here, HTTPS, stands for Hypertext Transfer Protocol, and S stands for secure. Now, if you notice, it says hypertext. So if we go back to here, hypertext markup language, if you notice the similarity between the two. So basically, HTTP is the protocol that is used for transferring this HTML document. HTTP is the protocol that's used for transferring the HTML document. So it transfers the HTML document from the web server of the company to the computer that you are browsing on, to your browser on the computer. So the the protocol is basically an indication as to what you are accessing. So if you notice, if I check my browser here and the protocol that I'm using, it says file. That's the indication that I'm accessing a file and not a web page. So that's my protocol there in my URL. Now, after that protocol, you can have, well, a part of it is the colon and double slash. Now, from store.com to websitename.com, sorry, store.websitename.com, that is called your domain name. Now, this extra part is called a subdomain. So from website name to .com, that's called your domain name. Now, this here .com is called a top level domain, and there's some common ones that you guys might already be familiar with. Top level domain. Right, this is why I don't like using Bing. Everything except what I wanted. Yes, this is what I wanted. So .com for commercial sites, .org for organizations, .net for networks, .info for information platforms, .biz for businesses, .edu for education, and so on. So those are some common top level domains you might come across. UK for United Kingdom, GY for Guyana, and so on. Now, after the domain name, you're going to see some slash with some, this is called the file path. So this is where you're going to go to different parts of the website. So those are the major parts you need to take note of: the protocol, domain name, and the file path. All right, so what is the difference between a web page and a website? So a web page is basically a single page. It's referring to a single page. And a website is basically a collection of web page. You have what is called a static website. A static website, when something is static, it means it doesn't change, it doesn't update. It's like a brochure. They're just having content on that website. You have dynamic websites, and that's the websites that we have today. They're constantly changing, constantly updating. E-commerce websites, those are for businesses. Then you have web applications. Those are literal applications that run through the browser, through an application that is running on the internet. Then we have another grouping of types of websites here. We have websites for educational purposes, corporate purposes, shopping, social media, academic, personal, mobile, directory. Now remember, there's a difference between a mobile website and a website that is developed for maybe a desktop or a laptop. The viewing of it, as you would know if you would access a website from a phone or a computer, there's a difference in the appearance of it. Now, what are breadcrumbs? Breadcrumbs is basically a file path to get to a certain part of a website. So, like for instance, you'd have to go through the home page, then another page called plants, then another page called potted, another page called flowers. So, the breadcrumbs is the path you take to go through to a certain part of a website. Remember, a hyperlink can take you to um, another. Hyperlinks are used to connect to web pages, to other web pages. It could be linked to the same web page, or it can allow you to download or access a document. So take you to another web page, same page, or access another document. Now this is the basic layout of a website. A website would have a header section. That header section would have the name of the website, web page, blog name, logo, company name. The footer is going to contain any other additional information, like maybe contact information, copyright, legal information. The contact section, obviously, that's going to contain the main content of the website. The sidebars are for navigational bars or menus, basically area to navigate the website, additional information. Now, you may or may not be asked to create one of this here. I forgot what this is called, but this is basically planning the structure of a website. All websites, they must start with a home page. And from that home page, is where you can access your other, like, think of it like main heading, sub, and then your various subheadings. So that's how you would organize a website. So these pages, you could think of it as being like heading level one, and then under the necessary page or heading, you would have your appropriate pages underneath them. All right, so we're gonna run through Word quickly, and then we're gonna wrap up there. So that's it for websites. All right, so Microsoft Word, or did we already run through Word? No, I think we only did. No, it was Excel because we were looking at format. Format Painter is the same for, as we covered in Excel. All of these, da 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 da, da 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 da. Okay, so a question might be how to create a table of contents. So to create a table of contents, first you need to do is to have your heading. So for example, heading 1, heading 2, heading 3, and then you need to style your appropriate heading. So this might be, you might style it as a heading 1, you might style that one as a heading 2, style this one as a heading 3. So you have your necessary headings, and then you place your cursor at the designated area. You go to your, is it the reference tab? Yes, you go to the reference tab. So the table of contents option is under the reference tab. You select table of contents, and then you basically select your appropriate design that you want, and you have your table of contents. So does your table of contents automatically update? The answer is no. How do you update? You click on your table of contents and you select update table. Now in the update table option, you're gonna have two. You're gonna have update page number only. So that's if you just want to update the page numbers only, straightforward, or update the entire table. Um, what other options do we have? All right, so under the insert tab, cover page, page break, no. All right, header and footer, remember those are used for repeating information, whether under the header or footer. Page number, that's under the insert tab. Literally, they might ask you what are the steps for inserting a page number. That's under the insert tab. Um, they might ask you how can you get page number, different page number on different pages. Remember, that's a combination of page number and your section break. So you would have to use either, more than likely, it's going to be a next page section break so that you can have different page numbers in your document. Let's see. Layout. So under the layout tab, you have your margin option, orientation option, changing your file size, columns, those are straightforward. Now the section break. Um, Remember, the purpose of a section break is to have different paragraph formatting. Paragraph formatting is going to include things like having different margins, having different page orientation, having different page sizes, having different columns, and so on, and having different page numbers. So those are the different options you can have because of section break. Um, well, under the reference tab, we already looked at table of contents. Footnote and endnote, where do those go? So if you insert a footnote, remember that goes to the end of the page that contains that footnote. However, an endnote goes to if you insert an endnote, if you notice it's right here, because an endnote goes to the end of a section or the end of the document. And right now, this is actually the end of the document. How is this the end of the document? We got all this space at the bottom here. This is the end because there's literally no space. Until I press enter, then we're going to get some space there. So that's the actual end of the document there. So endnotes go to the end of the document, end of a section, while footnotes are at the bottom of a page. What are the purpose for them? They're basically used for adding additional information. All right, we're gonna look at the textbook for that. Mail merge, comments, developer tab. Remember, your controls are under your developer tab. If they ask you questions on how to insert your controls. All right, let us run through the chapter quickly on Word. I think there's some necessary things you need to remember. Margin, paper size, series orientation, add in fonts. All right, so remember the difference between save and save as. So save is used for saving a current document, while save as is used for saving a new document. Well, we already looked at format painter, page numbering, indenting. Find and replace, well, that should be straightforward. Remember the shortcut for that, that would be Control and H. You find something and you replace it. Headers, footers, section break, footnotes, and notes. Creating a table. Remember, creating a table is simply go to the Insert tab, click on Table, and you just move your cursor across how much rows or columns you want to be inserted. Alright, so this is the one I wanted to show you, track changes. So track changes is a feature that allows you to review a document. It shows you the changes that you would have made in a document. So what you need to remember on that is that if it is red with text crossed out, that means something was deleted. And as you insert text, it will be typed in a color, and it will be underlined. So just remember for track changes, if you delete, it's basically to show how a document was edited or how it was changed, track the changes. So if it was something was deleted, it's going to be shown in red with a line through it. If it was added, it's going to show, I think it's green or blue, and then it's going to be underlined. Comments, well, comments go to the end of a document, not the end, to the right hand side of a document to add additional information. Oh, protecting a document. This is important to note. If you go to File and then you go to Info, you have Protect Documents, and these here, um, you must, well, they might question you on them. So this always open read only. This one here is used if you guys remember, sometime when you open a document, a yellow bar might appear at the top here asking you to click to enable editing. That is that can be enforced by this option here. It's usually to prevent the person from accidentally making changes. So like when you open a document, instead of you randomly pressing on the keyboard and it made unnecessary changes, it prevents those changes. You gotta enable the editing. Encrypted password, that's straightforward. It protects us with a password. Restrict editing, that controls what the person can change. Restrict access. Um, I guess you're gonna add certain peoples to the document, add a signature. Now this one here, mark as final. This is gonna indicate to the person that this is the final version of the document. So those are some of the means of protecting your documents. All right, so we already looked at generating a table of contents, how to update the table of contents. All right, mail merge. Now, mail merge is basically used for when you want to send a lot of like similar types of mail to a particular person. So, what is necessary for a mail merge? What you need firstly is what is called a primary document. This is also called a original letter. This is basically your template. This template is going to have all the similar information that needs to be sent to everyone, like you see in this example here. And it's going to also include what is called merge fields. So the merge fields is the indication where the unique information is going to be going. So if you notice all of this here, this is the similar information among everyone. And the merge fields is an indication where the unique information will be going. Now, the merge fields pull the information from the document that's called the secondary document. Now, this secondary document can either be a database file, an Excel file, could be a Word document file, any sort of file it could be. Once the data was documented and separated correctly. So like for instance, if it was documented in a table format. So these are the two important documents that you need for a mail merge. You have your temporary or your template, which is your primary or original, and your secondary document, which has all of the unique information separated. Now, and when you carry out the merge, that is called a merged letter. So just in case they ask you a question how to carry out a mail merge, just pretend we already created our secondary document. You go to the mailings tab, you select start mail merge, and you can either go through the wizard or select if you want to create a letter, the steps for it, that you want to create a letter. or we can work with the wizard. Select any step-by-step mail merge. Indicate that you want to create a letter. You're using the current documents. You add your secondary document. You browse and add your secondary document. I'm not sure if you're gonna have. Oh. Yes, you browse and add your secondary documents. The information will appear. Now, if they show you an image of this here, these checkboxes are used to indicate whether you want that information to appear or not. So if you don't want a particular person, assume information to appear, you can simply uncheck it, and that would ensure that information does not appear in the letter. So if you want all needs to be checked. The secondary document was added. You continue with the wizard. You enter your merge fields. The next step is to enter your merge fields. You do that by going to insert merge fields and selecting the necessary merge fields in the appropriate locations. Then you have the preview option to preview the information, and then we can use the finish and merge to get our final document. So we click on edit individual documents. Now in this box here, if you want all of the letters, obviously we select all. If you want the current documents that you're working on, that's that. Or if you want to arrange, you go to this option here. So let's remember you have those options for your mail merge output. That's basically the steps. Mail-ins, start mail merge. You go to the wizard, type your documents, insert your merge fields. Well, before you insert your merge fields, you need to add your secondary document. Then you insert your merge fields. Then you complete your merge. You do select finish and merge, and whichever is the appropriate option. All right, so remember creating a form. The options are called controls. They're used for entering your information into a form. You have the text control, the checkbox control, the combo box control, the drop down list control. And I think that is it for Word. Yeah. Yep, that's it for Word. So that is it. That's as much I can try to help you guys. So all the best to tomorrow. You need your rest also. Anybody with any questions though? Before we wrap up. Like I said, chapters 1 to 4, that's basically theory, just reading and memorizing. But 5 all the way to 10, they will ask you some practical questions. How to create table of contents, how to do the mail merge, how to create a chart, how to create a calculated field. They will ask you questions along those lines. So you got to remember the steps, where those features, what tabs they're under, and how to basically carry it out. Yes. So if no questions, thank you for attending. All the best for tomorrow. You're welcome.